So today we're going to do number 11 from chapter 13. The question reads, free fall acceleration on the surface of the moon is about 1/6 that on the surface of the Earth. The radius of the moon is about 1/4 of the radius of the Earth. Find the ratio of their average densities, which is Greek P moon over Greek P Earth, which is just density of moon over density of Earth. So I wrote down the givens, which is they're listed there, and then our equation, which is the gravitational acceleration equals the gravitational constant, the mass of the object, and then the radius of the object. And so now we kind of want to find a density equation that's not specific to either planet or any planet. So we're going to go with P is equal to mass over volume, and rearranging this one we get M is equal to G R squared over big G, and then our volume is, well, we're assuming they're spheres, like they're perfect spheres, so our volumes are 4/3 pi r cubed, excuse me, and then so these are pretty basic and they aren't specific, so we get G R squared over big G 4 pi r cubed over 3. So this r cubed is going to cancel with that, cancel out this r squared, and then moving around variables we get 4 pi with 3g and the big G on bottom, and this is equal to P, and our radius is also on the bottom. And so this is the density of an unknown body, this is the gravitational pull of an unknown body, this is the radius of the unknown body. So now we are going to substitute in variables, and since we have a ratio, we know that all the constants are going to drop out, so 3, 4, pi, and g are going to cancel out, so we are left with P moon over P earth equals G of the moon over R of the moon all over G of the earth over R of the earth. And then, so we're going to sub in using these givens into this formula, and we get, we're going to sub out Earth because we don't want to use fractions. So we get G moon, and then so this would go over here, and this would go over here when you flip the fraction. And then so the G Earth is equal to 6G moon. The G moons are going to cancel, leaving the 6 out front. And then the R of the moon is going to go on top, and the R of the earth is going to go on top, and that's actually 4 R moon, and then this R moon stays on the bottom of the fraction. So the R moons cancel out, and you're left with 4 over 6, which simplifies to 2/3, and that is the density of the moon as compared to the density of the earth.